So hi everyone, today we are going to see this easy problem in LeetCode called implement queue using stacks. Okay, so let's just see what the question says. So it says us to implement a first in first out queue, okay, using only two stacks. Okay, we are only supposed to use two stacks and we are supposed to implement a queue for it. So what are all the operations of a queue? We need to implement the push functionality peek, which just returns the top element of the queue or the front of the queue without kind of removing it. It just tells us what the first element is, whereas pop will remove it. So the only difference between peek and pop is pop will remove the element and give you the element, peek will just give you the element, it won't remove it. And another function called empty. So we are supposed to implement these three functionalities or these four functionalities, and yeah, that is it. There's nothing much we need to go around in this problem. So I have actually solved this, and let me just explain you how this works. So let's say we want a queue, right? So we had to implement a queue, and let us suppose this is the queue that we want to implement, okay, and we are given two stacks, right? So I'll just take a couple of examples and I'll just show you how this works so that we could get some idea on what is happening. Okay, so now someone says just push one into the queue. Fine, pushed one into the queue. So I need to store it somewhere. Let's say I store it under stack 1, right? So push in queue is equivalent to pushing it into stack 1, and this is stack 2. And then someone says just push 2 into the queue. Fine. So internally, though this appears to be like a queue, we are internally going to use two stacks for this. So here we are going to say again push 2 to the queue. Fine, this also looks fine. So if someone says push 3, then we are again going to say push 3 into the queue. So this looks very easy as of now. And see that whatever the element, whenever someone says push to the queue, we are going to push it to the stack 1, right? So which is the functionality we have implemented? The push functionality. So if you see here, the push functionality, what we have done is, if someone says me to push an integer element x into the queue, all I am doing is just pushing it into the stack 1. Okay, so whatever we have done visually is what I have represented here. Okay, this looks fine, right? So nothing much complicated. Push functionality in a queue is being implemented, right? Now comes the other part. Now let's say someone wants us to pop from a queue, right? Pop from the queue meaning he wants me to get 1. Okay, so someone says give me the first element in the queue or the front of the queue, so I must be in a position to return 1. But if you see here, 1 is at the bottom of the stack and we cannot access 1 unless all of these are removed. So this is where the idea of the second stack comes in. Actually implementing a queue using a single stack is not possible because you need some way to store these elements, right? So what we do here is we just say stack 1's element 3 just go into stack 2. So top of this will go here. Anyhow, this is trivial, right? So you just say s1 pop and then you take that element and you pass it to s2 push. So this is very simple, right? You just push it until when, as long as you have one element, because one element is what you are going to do. So you push 2 here, and naturally these two elements, right? These two elements would go off. So you will no more have 3 and you will no more have 2, right? All you have is just 1. So now you have arrived at your motto. Now you will just say stack 1 dot pop. Simple. So you get the 1 and you return the 1 to the caller of it. Now ideally speaking, you won't even have your 1 here because 1 is being popped from the stack and it is returned. You didn't store 1. Observe that 1 is not being stored anywhere. So now you have your 2. So just bring back all the 2 here. So 2 you had there, 2 here, 3 you had there, 3 here, you'll bring it, and then you'll make again, this stack will again get empty. So the critical idea or the critical thinking that you have to have here is, why did we pop? Why did we remove the elements from here and put it here. So this is a very very detailing to the problem that you have to give, because once you remove an element from here and you push it here, or once you remove an element from here and push it there, the ordering of the elements get changed. If you observe earlier, we had 1 here, right? And before we popped out 1, so we had 1 2 3, but once you push it to the stack 2, the ordering has changed. So 3 has come to the bottom and 2 has come above it, and this is not the ordering which is being there in the queue. It's not, our queue is not like this, right? So our this structure represents this queue, and our queue is not like that. Our queue is 2 3. So you need to remove these elements from stack 2 and push it back to stack 1, so that the ordering of the elements is being preserved. So now 2 3 represents your 2 3 in the queue, which is perfectly fine. So this is how we would implement the pop functionality of the queue. So in a nutshell, I would just summarize this by telling, we wanted the bottommost element of stack 1, yes, but we cannot access the bottommost element of a stack. Why? Stack doesn't work that way. Whichever element you put to it in the last would be the last one to come out. So you can't get the first element asking when you are at some point when you are away from the first element, right? So we remove all the elements in stack 1 and push it to stack 2. Why should you only use stack 2? Well, there's no exact reasoning you should use a stack 2. You can even use a list, like an array list also would work fine. You can just pop these elements, store it in an array list, and push them back from the array list. So stack 2 is just a fancy thing that they have used here, but even an array list way of storing the popped elements from stack 1 would work. Okay, so that part is clear, right? So now we would just say 3. And yeah, so then we remove the elements back here, and I have told you the reasoning as to why we remove elements from stack 2 and put it in stack 1 again. So let us see, now we have looked at the pop functionality of the queue, so we'll see pop functionality. See, so this is what we are doing. So what does this part of the code do? So this part basically says, as long as you have more than one element in your stack, just pop it up and push it to the stack. So I'm popping it out, storing in this variable, and I'm pushing it. So this looks very simple, right? The functionality that we have implemented, we pushed 2, we pushed 3 to this stack. So this is what this loop will do. And now you're rest assured that at this point, the size of the stack is only going to be 1. Why is that the case? It has to be 1, right? So it is because of this condition. It is because the stack size was 1. We did not execute or go inside this loop. So the stack size at this point is 1, and if you pop that element, you get the head of the stack, or sorry, the head of the queue. So then you have the head of the queue, and actually this is what you are supposed to return. And actually you could just say, return head of queue. So this would work, but this will not ensure, this would work just for the time being, but our ordering is different. See, this ordering, we had to push it back here. We had to push all the elements back into stack 1. If this is not done, the ordering of the queue would not be preserved, right? So for this reason, putting this line at this point is not a good idea, but we would again say, while stack 2 has elements, just remove all the elements, just pop all the elements of stack 2 and push it in stack 1. So this would ensure that our stack preserves the queue that we had initially, and then we would return the head of the queue. Very simple. So this is how we would implement the pop functionality. Now we have this peek. So I told you the difference between the pop and the peek function is, here we are popping the element, and here we don't pop, we just return the element. So see here, we don't pop, but rather we just return the element, right? So here we just return the element, and then we finally we don't pop it. So if this, you replace this with pop, this would be the this would be the pop functionality, but we just want to peek. So we just peek in to the stack 1, and then we just return this elements. So this is how the peek functionality would work. And anyhow, this isEmpty function is quite trivial, because our stack 2, if you observe at any point, is what represents what the queue is. So whatever is the queue, our stack 2 will have. So now if you ask me, is queue empty or not, then I would simply ask myself, is stack 1 empty or not? If stack 1 is empty, which implies my queue is also empty. So I just put return stack 1 is empty, right? Stack1 dot is empty. So this will say whether my stack1 is empty, which internally logically reflects to queue being empty or not, and I would return. So I have actually returned these changes here, and let's try submitting this once. Okay, let's try running this once. If we get the correct result, yeah, it got accepted. And now let's submit this. Let's see what happens. Yeah, it got accepted. So yeah, this is a good problem you can solve. This is a very easy problem in LeetCode, and yeah, but anyhow, solving a problem is good. So this is for today's video, and yeah, thank you.